Welcome back, 6th grade. Today we are talking about probability. But instead of talking about independent events, which we have been talking about, we're going to be talking about dependent events. But before I get into those definitions, I want you to stay tuned for help with starred problems for your homework problems. So at the end of the lesson, I'm going to be going over some of the starred problems in today's written practice. So make sure that you watch the whole video and that you stick around for those starred problems. Okay, so let's talk about our independent event. That is what we have been doing thus far when we've been talking about probability. We've been talking about an event that is not affected. So we're going to put not affected by any other event. So an example of this would be we toss a coin and then we spin a spinner. The coin toss does not affect our spinner. If we get heads on our coin toss and then we spin a spinner and we get a 2 on our spinner, that head, getting a head on the toss doesn't affect our spinner, right? They're totally independent events. There's going to be no effect on them. But a dependent event is different. A dependent event is affected. Where something is affected, our event is affected by something that has already happened. So that's what our discussion is today, our dependent events. So let's look at example 1. We have 2 red marbles, 3 white marbles, and 4 blue marbles in a bag. If one marble is drawn, so here we have one marble is drawn and then not replaced, meaning that marble is not put back in the bag, and then a second marble is drawn, what is the probability that both marbles will be red? So let's look at the information that we're given. We have 2 red marbles. So 2 red. And then we have 3 white marbles. So 3 white. And we have 4 blue marbles. So 4 blue marbles. And now they're telling us that one marble is drawn and not replaced, and a second marble is drawn. And we want to know what's going to happen, the probability if both marbles will be red. So probability that we have red, and then we want to know probability that we'll have red after another red. So let's first look at just this first probability, that we have a marble drawn that is red. If one marble is drawn and it's red. So first we need to know how many total marbles we have. Well, 2 plus 3 is 5, plus 4 is 9. So we have 9 marbles. So our total possible is 9. We have 2 red marbles. So we could have our 2 favorable outcomes are, well, our number of favorable outcomes are 2. So we could have 2 out of 9. So that is our first probability. Our first event that's going to happen here is we have a probability of pulling a red marble out of our bag is 2 out of 9. But now we're going to do a second marble. And this marble that we just pulled out is not going to be replaced. So now we have 1 red marble and we have 8 total marbles. So now instead of my total possible being 9, my total possible is 8. And instead of my favorable being 2, my favorable is really 1. Because I only have 1 red marble left, and I only have 8 marbles in my bag. So to pull another red marble after having a red would be one red marbles left, and I have a total of 8 in my bag. And now, just like we do with our other probability, we multiply these two together. 2/9 multiplied by 1/8. And I can cross cancel these out, right? My 2 and my 8, that becomes a 1. This becomes a 4. So I have 1/36. So my probability that both marbles will be red, that I'll pull a red and then a red again, is 1/36. All right, let's look at example 2. Okay, we have 2 cards are drawn from a regular shuffle deck. What is the probability of drawing 2 aces? Okay, so you have to have some background information here. Shuffle deck. They're talking about a standard deck of cards, of playing cards. So you need to know that our standard deck has 52 cards. And that our standard deck has 4 aces in them. So that's some background information you need to know about playing cards. Playing cards where there's different games you can play. One of the ones you're probably most familiar with is like poker. You see that on TV, you know, but there's a lot of other games you can play with that as well. Poker is a gambling game, so none of you should be playing that, but that's something you're probably familiar with seeing it on TV. We do live in Vegas, so you're probably familiar with some of these games. But in case you're not, that's what they're talking about. Okay, so you need to have that information. So they want to know if 2 cards are drawn, what is the probability of drawing 2 aces? Well, remember, we're going to set our problem up where we have the probability of an ace, and then we want to know the probability of an ace after an ace. Okay? So my first ace, right, if I have 4 aces and 52 cards, well, that is 4 out of 52. But now over here, I'm down to 3 aces and I'm down to 51 cards. So now having an ace after pulling an ace, I'm at 3 out of 51. So now we're going to multiply these two together to find our probability of the 2 events, or of this event. Well, I can reduce 4/52 to 1/13. So I'm going to do that first. I can also reduce 3/51 to 1/17. So now I'm just multiplying 1 over 13 times 1 over 17. And my answer becomes 1 over 13 times 17, which is 221. Okay, so that is the end of the lesson. Pretty quick lesson. Go ahead and do the practice set in the Google form. And then written practice, odd problems. I'm going to go ahead and we're going to do a few of the odd starred problems together so that you can make sure that you're understanding our recent lessons. So let's look at number 7. The number that is 20% less than 360 is what percent of 360? Okay, so this is kind of a weird question. It's asked in a weird way. Okay, so let's think about this. It says the number that is 20% less than 360 is what percent of 360? Well, they're not saying what number, they're saying the number. They're asking for what percent. What percent? That's why it's important that we write our information given and what we're asked to find. So they're asking for what percent. What percent of 360 is 20% less than? Well, all we have to do is 100% minus 20% equals 80%. Because we're always going to start with 100%. So that's our answer. Our answer is 80%. Okay, let's do number 9. Number 9 says to use 2 unit multipliers to perform each conversion. So let's just look at A. So for A, we need to take 144 feet squared and convert that to yards squared, to square yards. Okay, so we know that to go from feet to yard, we have 3 feet equals 1 yard. So that's going to be, this is going to be what we use as our unit. And now we need to put it into a unit multiplier so that we can convert this. So we have 144, and because I have 2 feet, I'm going to have feet times, I'll actually do a different color here so we can follow along. Feet times feet. And then we need to have our unit multiplier. Well, remember that I want to be able to cancel out my feet. So I'm going to put my 3 feet down here and my 1 yard up here. Well, that's only going to cancel out one of these. So I'm going to do another unit multiplier. Same thing. And I'm going to cancel out the other foot. And that should be able to give me my full thing. So I'm going to cancel out foot, 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 foot. And I end up with 144 times a yard. See? 144 times a yard times a yard all over 3 times 3, which is 9. Now 144 divided by 9 gives me 16, and I have a yards squared. That's my yards squared right there. So there is my final answer for A. Okay, so that's A. Let's look at B. Now B, we have to use 2 unit multipliers because we are going to be taking 1 kilometer to millimeters. And I can't jump from a kilometer to a millimeter. I want to stop at meters in between. So for B, I know that 1,000 meters equals 1 kilometer, and I know that 1 meter equals 1,000 millimeters. So these are going to be my units to make my unit multipliers. So let's set up my problem. I have 1 kilometer, and I want to get, in the end, I want to get to millimeters. So I'm going to multiply that by a unit rate, and I'm going to multiply it by a unit rate. Well, I want to have my kilometers crossed out right here. So I'm going to put 1 kilometer down here and 1,000 meters up there. Now again, I don't want my answer to be in meters, so I'm going to have my meters cross out. So I'm going to put, for my next unit rate, 1 meter down here and 1,000 millimeters up there. And now I'm going to show you how I cross everything out. There's my kilometers crossed out. There's my meters crossed out. And now I finish. I have 1 times 1,000 times 1,000 millimeters all over 1 times 1. So 1. So that's nothing. So I have 1,000 times 1,000 gives me 1 million millimeters. Okay, 21. This is the last one I'm going to do. First, we need to fill in our table using our function y equals 3x. Then we're going to graph the function, and then they ask us if x and y are directly proportional. If this is a direct proportion, y or y not. So first we need to do the equation y equals 3x and fill in each of these to finish out the equation. Okay, so let's see. Y equals 3 times 1, then which would equal 3. So this would be 3. Y equals 3 times 0. This would be 0. And y equals 3 times -1. This would be a -3. Okay, so now that we have completed our table, we can now go and graph our function. So I am going to set up my graph. And I'm going to go ahead and just erase this so I have room for my graph. I'm going to create, my x. Remember that, excuse me, that's my y. And my x coordinates. Okay, so first I want to make this coordinates just like that, 1, 3. So X comes first, right? X comes first because it's first in the alphabet. Also, I read left to right. So I start with how I read. So this becomes a 1. And then I go up 3. 1, 2, 3. So here is my first coordinate. My next coordinate would be 0, 0. Well, that's my origin. So that's right there at the origin. My last coordinate would be -1, -3. So this time, if this is my standard number line, -1 is right here. And then I go down 3. 1, 2, 3. Okay, and then you can connect the dots. Okay, and your graph should look better than mine because I don't have a ruler over here. But I've connected the dots and it is going to be a straight line. Okay, so then my answer for C is yes, it is directly proportional, because if you remember from our investigation 9, it is a line and it goes through 0, 0. So a line that passes through the origin is directly proportional. Okay, so those are all the ones I'm going to do today. And thank you for watching, and submit your homework and have a great day. Bye.